Hey guys, I'm here to help you study for your factoring test, and so I'm going to put together a couple videos to help you through this. And just so that this is clear, I'll say it in class, but I'll say it here as well. This video will only focus on the first page of the homework review packet, which will only cover questions 1 through 5. So if you want a different page of the packet, go to the video that reflects the page of the packet. So video 2 will cover page 2 of your packet. Video 3 will cover page 3, and then video 4 will cover the 4th page of your packet. So anyway, I'm going to get started, and I'm going to read the question and then kind of help you listen to how I process through how to answer the question. So for number 1, it says, sometimes you can save time by factoring out what is called the greatest common factor. We've called that GCF. And which expression below one, A, B, C, D for number 1 would have a GCF? Now, as I'm looking at my problems, what I want to do is see if all the terms have something in common that I can divide out. Well, 4 and 25 do not have a factor in common. X squared, 15x, and 36 do not have anything in common. 3x squared, 5x, and 8, those do not have anything in common. And so the only option left would be letter D. And what they have in common, so if you were asked to factor it with the greatest common factor, 18 and 3 are both divisible by a 3. And both of these terms, how you factor out the letters, would be to factor out the letter with the smallest power. So the smallest power on the x is a square, and that would be what you could factor out. So this is our GCF. And now you would write out the factor of what remains after you divide out the 3 and 2 x's. For my first term, I'd be left with 1x. And for my second term, I'd be left with 6. And that would be how you factor out the GCF. For number 2, it says, which expression below is a difference of 2 perfect squares? Now, difference, the key word here is that you have a subtraction sign in between your 2 terms. So as I'm looking at these options, I'm going to immediately cross off choice D because there's a plus sign, and a plus sign is not a difference. A plus sign is a sum. Then as I look at the choices that I have left, I want to look for 2 perfect squares. 2 is not a perfect square, and neither is 6. And even if I factored out the GCF of the 2, I'd be left with x squared minus 3. 3 is not a perfect square, so I'm going to cancel option B. And like we did up here, this letter C repeats from what we had from letter D up above. If I factor out the GCF, I'm still not left with perfect squares. But 4x squared is a perfect square. Its roots would be a 2x and a 2x. And the roots, the square roots of 25 would be a 5. And how you factor a difference of 2 squares would be one factor gets a minus, one factor gets a plus. The order of that doesn't matter. So A here is your choice. Number 3 says, which expression below would be used for factor by grouping? In order to do a grouping, you need to have 4 terms. There is only one option below here that has 4 terms, and that would be letter B. If you were asked on your test to factor, which is what you're going to have to do, this is how you would factor 4 terms. You take just the first 2 terms and you factor out the GCF of just those 2. In x cubed and 3x squared, my GCF would be an x squared. And if I take out the GCF of x squared, if I divide that out, I'd be left with 1x minus 3x squared. If I take away the x squared part, I'd be left with a 3. And then I group the next 2 terms as a group. 4x minus 12, the GCF that those have in common would be the number 4. They're both divisible by a 4. And if I divide away the 4, I'd have x minus 3. Now, when these 2 groups match, grouping works. So one of the answers, your factors, will be x minus 3. Pull the GCFs together, and this is your second factor answer. Number 4 says, which expression below has an A value greater than 1? And therefore, you would use what's called split the middle, or I learned this one, snowflake, in Minnesota. But which one of these, A value greater than 1? This is off of the factor flow chart that you had. An A greater than 1, what we're looking for is an AX squared, a BX term, and a C. And so we want to look for a number in front of our x squared term that is greater than 1. These trinomials have 3 terms, so I would not use that method for A because this only has 2 terms, and when we learned split the middle, we were learning it with 3 terms, so A doesn't have 3 terms, so that would not be my option. Option B has 1x squared, and that is not an A greater than 1, so I would not do option B. Now, as I'm looking between C and D, A greater than 1 for a trinomial that has a square, a quadratic lead term, would not be a grouping that has 4 terms. So I'm going to say not letter D, which leaves me with only one option left, 2x squared plus x minus 10. Now, if you were asked to factor this is how we taught it. I taught it to you in class. So if you have 2x squared plus an x minus 10, this is how I would solve this problem. I would start by taking my 2 times my negative 10, and I did what was called the big X method. So I would take my A and my C and multiply those together, and I get negative 20. My middle term would go at the bottom of my big X, and now I would come up with 2 numbers that multiply to make negative 20 and add to make positive 1. And as I'm thinking of 2 numbers, I'm thinking of a positive 5 and a negative 4. Now these 2 terms split the middle term. So instead of writing it as 1x, I'm going to write it as 2 terms, a 5x and a negative 4x. So instead I'll have 2x squared plus a 5x minus a 4x and minus 10. Now that I have 4 terms, now I'm going to solve it by grouping. But again, my 1x got redone as 2 separate terms. That's why I call it split the middle. My 1x got split into a 5 and a minus 4, and I got those numbers from my big X, my A times C, and my B term here. And now you factor by grouping. My first 2 terms as a group, what is in common here? And the only thing that they have in common is an x. If I take out the x, I would be left with 2x plus 5. And now if I look at my next 2 terms, both of these are negative. So I'm going to take that out. That's in common. And both of these 2 terms are divisible by 2. And if I divide each of those by negative 2, negative 4 divided by negative 2 is positive 2 with an x. Negative 10 divided by negative 2 is positive 5. Now when these group match, that means grouping worked. So you can factor by grouping. So you have 2x plus 5 as one of the groups, your factor groups, and then x minus 2 as the other. And that would be your answer for solving number 4. Number 5 says, which expression below is a perfect square trinomial? This means that your lead term is a perfect square, and your last term is a perfect square, and your middle term, because it says trinomial, so I'm looking at C here. This is not a trinomial, that's a binomial. Your middle term should be the number 2 times your root of the first term times the root of the second term. So I'll talk about that here. So you should have 3 terms. I'm looking at the first one, and I do have 3 terms. My first term is a perfect square. My last term is a perfect square. So what I need to do is check that it fits the perfect square trinomial, which would mean, I'll show you this, that if I take my first term and I write out what its roots are, I'd have x times x, and the roots of 9 would be a 3 times a 3. Now this is how you check to confirm it is a perfect square trinomial. You take the number 2 times 1 root of the first times 1 root of the last term, and you see if when you multiply these together you get your middle term. Well, here I do get 6x, and that just means when I factor, I'm going to use an x and a 3, but my middle sign will be the same sign as I have here, which will make this minus. So if you were to double check this, x minus 3 times an x minus 3, I'm going to get x squared minus 3x plus 9. Is that what I had to begin with? Yes. And this is a perfect square trinomial because your roots, your factors, these are identical. So A is my perfect square trinomial. Check the other middle terms. You'll see that they actually don't end up working out. So for example, my 8 and my 8 here, my 2 and my 2 here, 3x and 3x here, here x and x. If you work out your roots and you check this 2ab, your middle term will not work out. So A is your answer here. This is video 1. Check out the next video for the next page of your review packet.